Fíjese que no me había percatado. Es que hoy he estado con eso, he andado bien volado con eso de grabar las clases. Pero muchas gracias, Mauricio. Le agradezco muchísimo. Okay, yeah, then you can use this as a resource, right? So I already talked about the numbers, I already talked about like the relation they make, and let's continue talking about the mathematic sequences. So what are mathematic sequences? At the end, there are the collection of numbers, building a set of numbers, of course, understanding that this set of numbers is or are infinite, okay, never ends. And the members of the set follows a pattern. Each of the members will be following a pattern. Okay, it means that all the numbers of the sequence can be described by an algebraic expression. What is an algebraic expression? Don't worry about it. Then we're going to talk about this one, but I think you have an idea about what it is. So important information. Those are like general ideas related with the sequences. And here we're gonna have a set of elements, but each of the elements takes a position, starting from one and then goes until the infinite. Tendency is to the infinite. It's something that never ends, okay? Something else in here, and we have to mention this, is that we're gonna relate natural numbers that started from one, natural numbers, connected with real numbers, okay? So those sequences can be defined by a pattern. They will make, and they will make, sorry, two kind of sequences we're gonna study. The arithmetic sequences and the geometric sequences. Those are very interesting and are not the only one that exists, to be honest, but those are the ones that we care a lot because with this one, we can create relationships in mathematics. And with that relationship, we probably will create functions. And with the functions, we can create models to describe real situations. That's the main idea. So we're gonna focus in this example and probably you can help me to discover like what is the next element. Let's see the first sequence. And this is the notation, okay? It's a lowercase, but very big. And the letter N, which means, this means sequence in mathematics. And you're telling here that you have N terms of the sequence. How many terms? Well, right now we don't know. We can have as many as we want. But in this case, in this list, I have 1, 2, 3, 4, 5, 6. And for each of the elements, I have the first position, the second position, the third position, the fourth, the fifth, the sixth. And I think you can tell me who's next in the seventh position. You know, if you already discovered like what's the pattern?
27.
Why it will be 27?
Because 3 plus 4 equals 7. 7 plus 4 equals 11. 11 plus 4 equals 15. And that's it.
Excellent. You're right. The next one's 27. And if we continue, what will be the next one?
31.
31. It's true. And so on. So I think you already discovered the pattern. So good. Nice. So I think we're not going to have many troubles with this topic. I think so. I hope so. It's pretty easy. Okay, let's see the other one. You have another one. And again, it's a capital letter, but it have to be a little bit bigger. And this one, we have to work on probably something different. So I don't know who can tell me what is the next term in here. We start with 48, then we go with 24, then we go with 12, then we go with 6, with 3, with 3.5, with 3 over 4, 3 over 8. So what is the next one?
3 over 16.
12.
3 over 12 or 3 over 16?
3 over 12, I think.
12, I think.
3 over 12 or 3 over, 3 over 16.
3 over 16, I think.
Okay, I have 2 votes right now. This is not a democracy process, but at the end, we're gonna see like who's right. No, that's not the point. The point is be sure about what's happening. Like asking here, why you conclude that it's 3 over 12?
Because it's 1/2. You're doing it by 1/2.
Ah, so I'm getting the half of the number every time. Okay, so nice. I think you got it. I start like with, well, let's see, how can I make it like, well, this have to be bigger. I start with like 48. Got the half of this, which is 24. Got the half of this, which is 12. The half of this, which is 6. The half of this, which is 3. The density problem, the density property of the real numbers tells me that always is gonna be something there. What happens if I make this a little bigger? The half of 3 then, if I have 3 over here, the half of 3 will be like, okay, here is 2, there is 3. The half of 3 will be 3.5. But then the half of this will be, sorry, not the half of this one, this way. Yes, this is gonna be 3.5. Because it's between, two, sorry, 1, 2, and 3. And the half of 3, it's 3.5, which is like 1.5 over there. Then the half of this number will be there, which is 3/4. I mean, it's gonna be here. It's lesser and lesser every time. Question to you, and you must be sure about it, because we're getting the half and the half and the half of the number, making these smaller, I think so, right? Every time, every piece becomes smaller than the other one. I don't know if you already see this, already see that. Question to you, which of those is the smallest? First question, is 3/12 smaller than 3/16?
No, 3/16.
16th is smaller.
Is smaller. Okay, 3/16 is the smaller. So for that reason, the answer, no. Check this out. Every time you get the half of this number, for example, if you have something that's coded in 8s, if you have something that it's coded in 8s, let's see, I don't know, a number between 0 and 1. And if we cut this one in 8s, I have here half, I have here fourth, I have here, if you see I'm cutting half of the half of the half, right? The half of the pieces, I mean, I got 8s. If I cut these again in halves, I will get the 16s, not the 12s, okay? So the next one will be 3/60. And it's very interesting. Every time this goes and goes bigger on the denominator, but thinking in the number, it becomes to be smaller every time. Tending to be what number do you think? Tending to be what number? As much far away you are with this kind of sequence, which is like 1/2, like you say, but I don't know if it's like you're adding a half, you're dividing by 1/2. Well, you can tell me. But my question is, what this tends to be as I get far away? For example, in this one, if I'm far away, okay, going from 3, 7, 11, 15, 31, come on, this is gonna go big and huge every time. So huge, so big. What happened with this one? Next one will be 3/32. Next one, 3/64. 3/128. Just suppose you have a pizza. If you have a pizza, well, not one pizza. In this case, well, from 3/4, I think we can understand with the idea of the pizza. With one pizza, if you cut that pizza in 4 parts and you take 3, well, you're gonna have something good. I mean, a good slice. But if you have one pizza and you cut this one in 8 parts, the slice becomes smaller, right? What happens if you have one pizza and you cut it in 128 parts and you take 3? It's practically nothing, right? It's practically nothing. So this is tending to be what? As much far away you go. What do you think? The smaller, it's true, but talking about numbers, it's like getting to be a number, but it's not gonna be that number. It's got, excuse me?
0?
0, yes, nothing, okay? I mean, then you're gonna have, wow, I don't know, 3/, 1 million, suppose that you cut a piece in 1 million pieces, come on, you're not gonna have any, you're a little taste, that's it. So
It's decreasing, mister.
it's decreasing. That's the point I want to say. Some of those sequences goes increasing, some of those goes decreasing, but the most interesting part is that they never goes to a number. Okay, so this one have different tendencies, and normally this topic is a good connection too between the algebra and between the calculus. Yes. So let's start talking about those sequences, starting with the arithmetic sequence. The arithmetic sequence, it's very simple. It's easier than understand this one than the other one. Okay, we're gonna get it so quickly, I think so. In this sequence, we're gonna have the elements following a pattern given by an addition or subtraction of a number, and this addition stays always every time, like the one you discovered in the last exercise, adding 4 every time to get the next element. So it's pretty simple. So the main rule here works like this. This is the general way to write a sequence, okay? So you can write it over there. And I will make just one question. What do you think mean these an and these an plus 1? What do you think it is? No, any idea? I mean, if I ask you, my question is, what do you think means an, and then what means an plus 1?
Es la sucesión que sigue el término para que vaya, digamos así, por ejemplo, ese que tiene usted en la parte de abajo del example, digamos así como, ajá, digamos, hay, claro, por ejemplo, en el de arriba creo que sería algo así como que hay un número multiplicado, digamos, un número multiplicado por otro número, que si le sumamos ese nos va a dar algo así como el que tiene usted ahí en el example.
Okay, okay. I think
Idea is
you're
that
going
n
away. You're going
is
so
the
away.
excuse me,
Sorry.
n
Yes.
is the number of elements that are there, but plus 1 means that we're going to be adding 1 to each one. That is the pattern we're following, or the sequence.
Okay, if I ask you, or if I tell you, this is the 10th element of the sequence, what will be this one?
Okay, it's going to be 11.
The 11th, okay?
Yeah.
Simple.
Because we're adding 1 to each one.
Simple like that, okay? Got it, Tiffany, nice. So Tiffany today participates so good. So this letter N, it's related with that. I think that expression we have here many times, or probably we say to our children, te lo he dicho N veces. ¿Alguna vez le ha escuchado esa expresión? Te lo han dicho N veces, para referirse a que lo han dicho una cantidad, ¿verdad?, exorbitante de veces. Bueno, a eso se refiere este N. Este N representa como el límite, por decirlo así, un valor al cual se podría llegar. Sin embargo, no es el último valor. Siempre hay un valor más. A esto se refiere. Okay? So, in mathematics and in algebraic expressions, this is something you should copy too. Very important. We're going to have consecutive elements, and that's an important word, consecutive. And if I have my consecutive number and it's n, I mean, I have my first consecutive number n, then the number that goes next to this one is, and look that I'm using letters, sorry, not variable, not numbers, sorry. They represent any number right now. So what will be the next one? Two consecutive numbers, a little example, 1 and 2. They are next to each other. So how can I represent that relationship with letters? I think you have the idea. What would be the way to write that consecutive? No, any idea? Okay, here you have the answer. If you have n like your term, the next term will be n plus 1. Simple like that, okay? Of course, if you want your next, the consecutive of the consecutive, n plus 2. And let me tell you that this is the way that a mathematician starts working with the addition of expressions. And it's so hard because at the end, to add numbers like, I mean, 20 plus 100, well, they have to discover which is the consecutive of the consecutive of the consecutive, because at the end, in natural numbers, that's what exists, okay? Position of numbers. And this is related with the Peano's rule or the successor. He called these ones like the successor number of the other one, okay? So the main idea of the arithmetic sequence is that between any two consecutives, you're gonna have always the same difference, okay? So in general, this is a rule that we will apply later to compare or to conclude if one sequence is truly an arithmetic sequence or not. And it's something you're gonna try probably in exercises of the quiz. So here we have one example. Little example. If you see you have 1, 5, 9, 13, then 17, 21, 25, I think you can tell me what are the next three elements.
29,
29,
33,
33,
All right,
37.
and 37, nice. Of course, we can continue this and this never ends. So let me tell you something. What happened if I ask you, because for example, right now we have the elements. Okay, yeah, I'm checking these. Sorry, I'm checking the chat right now. And yeah, I was checking that Anna had some trouble. She was trying to connect many times. So don't worry, I mean, we are recording the class, okay? And it's gonna be useful, okay? So here, I mean, you can check it later. So here you have something, look, you have like your first element, your second, your third, your fourth, fifth. Let's write over there the ordinal. Well, here is third, second, first, fifth, the sixth, seventh, we have the eighth. We have until which one? Until the 10th one. What happened if I ask you to look for the number that is exactly in the 100 position? What will you do? Will you continue the counting?
No, then you use the formula.
Okay, what formula?
The an equals 4n minus 3.
Okay,
No.
nice, nice, it's true. So this is like a little idea, right? And normally in these exercises, related with probabilities, then you want to know every of the values in the position. And one way to describe any of these variables, any of these values in the first, second, third, fourth, fifth, sixth, any position is use this, which is the general form of the sequence. So first part of the topic we're going to study today is check if one sequence makes an arithmetic sequence. And the second part is discover the general form of the sequence, okay? This is something that Gauss proposed, and if you don't know who Gauss was, well, and he did that when he was a children. This is the prince of mathematics, I think so, he's called like that. And when he was a child, I don't know if you ever hear this history, when he was a children, the math teacher asked him and all his classmates to find the addition from the numbers 1 to 100. He did it like in 1 minute, but he wasn't thinking on add 1, 2, 3, 4, 5. No, he discovered a pattern. He decided to create a formula that describes all those numbers, and then finally, like doing some math on the formula, he discovered the addition of all those numbers. And honestly, this is something that we will do. So In this case, we have here an arithmetic sequence. It's true, because we already discovered that this difference will stay between those every time. But one way to write this or to know that is that if this really works for every of the numbers of the sequence, I mean, this is the only way to check if it's an arithmetic sequence. Okay? So following that rule, which was taken from here, that always that subtraction between the two consecutive numbers or the two consecutive elements of the sequence will stay with the same difference. And how can we write that in general? Okay, check this out. This is a little bit of algebra, as I told you, is the connection between those. And if our formula in the sequence is 4n minus 3, and I want to show you how this formula works very quickly. So I'm gonna ask to Kaylin. Hello, Kaylin. Can you hear me, Kaylin? Okay. Let's see, Mariana Gutierrez, can you hear me?
Yes, I'm
Hello.
here.
Okay, I need that you decide for a number you have on the list over there, 1, 5, 9, 13, 17, anyone you want. Just decide for one of those.
5.
5, okay, 5 is in the second position. How can you find 5 in the second position? So 5 is the second element of the sequence, which means the value of n is 2. Check this out. You're gonna have then 4 times 2, which is replace the value of n, minus 3. Tell me then, 4 times 2 minus 3, is it 5?
No.
No. 4
No.
times 2 is 8.
Yes.
And minus 3, it's 5.
Yes,
So,
it is. Sorry.
okay, yes, it is. You can describe any of these values just requesting for the position of this one. What happened with the 6th? Try it with the 6th, and you're gonna see that this works. What happened if I want the 6th term? So ace of 6, which is the 6th term of the sequence. And to get this one, all you have to do is multiply 4 times the 6th position, the value that is on the 6th position, or the 6th position, and discover that value. So 4 times 6
24
minus
and
3.
minus 321, so it's the number.
Here we have it. So if I ask you to get the number that is in the position 100, now I think you can get it with a simple multiplication and a simple subtraction. Now, of course, with this general form, we can describe any value. So that's why we can apply the rule on that formula. So check this out. This is how to compare or how to conclude if this is really a arithmetical sequence. Because if it's not an arithmetical sequence, well, it's just a sequence that we find over there. You cannot say that is the other kind because they are not like complementary each other or opposite each other, right? It's just like kind of sequences. What happens if I tell you what is the next element? What is the next term? You have to use this idea of n plus 1. We were talking at the beginning. And what you will do here is just describe this one, replacing that value of n by n plus 1. So you're going to have 4 times n plus 1 minus 3. Okay, through the properties we're going to study later, I think so. But I think you describe some of these properties of real number in the forum. For example, here, the distributive property. You're going to have 4n plus 4 minus 3. And this will be describing like the element that is next to that position you want. So if I want the element on the 5th position, then with this one, I can get the element in the 6th position. Okay, so what I have over there are the consecutive numbers. That's so important because right now, we cannot start trying. I don't know if you understand my point right now. I think that we can start like making the subtraction of the second with the first and see that always is 4. I mean, 5 minus 1 is 4. 9 minus 5 is 4. 13 minus 9 is 4, and so on. Can we stay doing this? I mean, we will never end. The only way to be sure is create a general formula, which is the general form of the sequence, and try this rule. So that's what we're gonna try. If the subtraction of those gave us the difference we expect and to have always in those numbers, of course, what is that difference? What is that difference?
4.
It's 4. I mean, if I made the subtraction of those things with letters, of those algebraic expressions, well, and it gave me 4, that's an arithmetic sequence. Let's see, let's check it. So applying that formula.
I have a question about that formula. So for this one, if the difference is 4, then how do I know the -3? Is it gonna be the same for all the sequences we try? How do we change it?
I mean, you're asking for by 4n minus 3.
That
Okay,
part.
that's the second part of the class, okay?
Oh.
Okay, right now we're focusing in, and if you see, yeah, that's what I will describe you later. But right now, what I want that you focus in is into see how to check if one sequence is arithmetic or not, because probably you're gonna have questions related with this on the test of this week. So let's apply the rule. Again, good question. I think it's like what the logic's asking you to ask. It's equal to that difference, which is 4. We're gonna check if this really makes 4. That's what we want to do. So let's check it out. Probably you're gonna see some algebraic process here. Don't worry, we're gonna study those. And well, you already make a little investigation about it. Okay, my idea with the forums is that you're gonna have always, or here is 4n minus 3. Always you're gonna have the chance to explore one topic that's gonna be useful for the next class. So right now we have this one, 4n minus 3, and the other one, which is described, sorry, no, I was correct, is 4n plus 1, because it's the successor, is the next one, the successor, minus 4n minus 3, which is a sub n. We really want to know if this makes 4, okay? That's what we want to try over there. This is a little proof to check if an arithmetic, well, if a sequence is an arithmetic sequence. Let's check it out, because at the end, if this gives us 4, that's gonna be the answer. I think that many of you focus in the addition and subtraction of polynomials. Okay, so and you see the comments of your classmates too. So I think that you know what's gonna happen here. We focus a lot in those like terms you mentioned a lot in the forum, that's so good. And we have to operate them, understanding that they, or the operation that will work with them, it's focused in the number they work with. Question, what is 4n minus 4n? Okay, because essentially that's what you have to join. 4n and negative 4n. It is
0n.
And look, I don't know if you make as well that photo, but I'm waiting for one observation here in the exercise, honestly. Especially with the negative sign. For those who investigate that in the photo. Do you see something wrong over there?
Can you cancel both instead of writing 0?
Okay, this is one idea, cancel both. But there is one little mistake here. And honestly, it's a common mistake I normally see here. Excuse me?
-3?
It's in the -3, you're right. Look, this negative sign, I consider this just affecting the 4. That's wrong. This negative sign is affecting both of them. So this -3 becomes +3. Be careful with that, okay? Be careful with that, okay? So I think that now we have this clear, and you will not make this mistake. We can consider the final answer of these because we can join them, the 1 and the 3. What is 1 plus 3?
4.
4. Is it the same difference we expect to have? Yes. Immediately we can say that it's true. This is an arithmetic sequence, and I don't have to be trying with all the values, okay? We already know it because here we make that proof, and at the end, it gave us a number, a 4. So what do we want to do? We want to study how to get the n term. the end term of these expressions is given by the formula. So we're gonna study how to get the formula. This is the next slide. And then we're gonna focus in something that is the sum of the first n terms. Okay, why? Because there are some applications related with this. You're gonna see a story problem related with this. It probably calls your attention. Any question about how to prove if something is arithmetic sequence or not? So immediately you can say, this sequence we have over here, an equals to for this one, let's copy it. It's an arithmetic sequence. Okay, you have to conclude it like that. It's an arithmetic sequence. We are 100% sure that this is an arithmetic sequence. Okay, let's go to the next part. And how can you get the general form of arithmetic sequence? The question that I think Ana Lucia was making. Okay, it's just focusing on next formula. Everything is based on formula here, so it's not complicated at all. You must just be sure about when you're gonna use it and how can you use it. For any arithmetic sequence, you're gonna consider next. A sub n or an means you're talking about the general form of the arithmetic sequence, and it requires next to be described or to be written. The first term of the sequence, always the first term or the first element, it's very important. Then you're gonna focus on make this n minus one and find the difference. Of course, the difference is something that we're going to suppose and accept, understanding that it will be following. I mean, all the terms of the. Sorry? Question?
Sorry, mister.
Okay. So, and that difference we have over there will be will be a value that we will suppose, okay, starting saying or supposing that the sequence we are working is an arithmetic sequence. So what is the general form of next arithmetic sequence? If you see, it starts with -1. Remember that this connects the ordinal numbers or the natural numbers from 1 to the infinite with real numbers. So here we have -1, 1, 3, 5, 7, 9. Don't know if you already discovered like the first, well, the first element is over there. And the difference. Those are the things we need to apply this formula to discover the general form we have in the last exercise. The question that Ana Lucia makes can be described here with this exercise. So we just need the first term. What is the first term? I think you're watching is -1, right? So who can tell me what's the difference? For the difference, again, we're gonna suppose this is an arithmetic sequence. Of course, we have to check it. What is the value between them? The difference between them? I mean, here you have to make
2.
1 minus -1. It's 2, right? It's always 2. Then the difference between 1 and 3 is 2. I mean, 3 and 1 is 2. The difference between 5 and 3 is 2. 7 and 5 is 2. 9 and 7 is 2. So that difference is 2. How can you write the general form that describes any value? Following the formula, it will be a sub n equals to our first term, -1, plus, let's follow in here, n minus 1 times the difference. So it will be n minus 1 times the difference, which is 2. Of course, here, what comes here is just apply some algebra. That's why I ask you to make a photo related with polynomials. Many of you focus in the addition, some of you focus in the multiplication. And well, how this exercise works, pretty simple. The a sub n, the formula we're gonna describe, or that will describe all those values, will be getted following next idea. You're gonna have -1 plus 2n minus 2, and focusing the like terms, we can finally get the answer, which will be, of course, writing first the n, the variable n expression, or you can write the -3 here, no problem. -3, I mean, you're working to negatives, right? -1 and -2, they make -3. So you can write this one like 2n minus 3. And check this out. This is the general formula or form that describe any of these values. If you want to see for the first term, which is -1, okay, 2 times 1, because of the first position, it's 2. 2 minus 3, come on, that's going to be -1. And so on. If you want to look for the second term is 1. So let's replace here, instead of n, 2. 2 times 2 is 4. 4 minus 3, 1. And so on for the rest. So this is the way to describe any value. And it's so important we consider this, okay? So in this formula, what happens if I ask you to find the 5th term, the 10th term, and the 200 term? Could you find it if we already know that the way we describe this sequence, this arithmetic sequence, is this one? I think that we can freely find that those values, any one we want, okay? Using the formula, of course. So it's a little way to try this formula. So can you tell me which is the 5th term? Just to show you the procedure, you have the formula over there.
7.
It will be?
7.
Here it is, right? It's 7, but using the formula, we can get it so quickly too. It's gonna be 2 times the 5th position, or the 5th term, minus 3. Yes, it's true, it's gonna be 7. 2 times 5 is 10, minus 3 is 7. Okay, there you have it, 10 minus 3, it's 7. Let's find out the 10th. We can continue counting, of course, but it's not gonna be a good idea. What is it you say?
2 times 10 minus 3 equals 10 minus 3.
Okay, it's gonna be 20 minus 3, 17. Amazing. And let's see what this is gonna be useful. Okay, you're gonna see that. So Gauss proposed that. Suppose that now you want to know the number in the position 200. How can you find that one? 2 times 200 minus 3. I think we can get it so quick.
400 minus 3, 397.
397. There he is. And yeah, we don't have to continue counting like, well, it's exactly that, right? From 9, continue counting 2 by 2. You're not gonna do it like that to guess or to find what is the number in the position 200, as you can see. So this first part of find any term of the sequence is gonna be useful then to find the addition of the terms in a sequence, which is the next part. And I think because of the time, I'm gonna have the little break always, okay, from 6 to 6:10. And that way we're gonna focus on this exercise, okay? We're gonna solve it right now. I think we have enough time. Let's talk about now the summation. And don't worry about of your notes, okay? Because I'm always sharing this whiteboard in the classroom. You can access this one then. So the summation is practically the addition of the first terms you want. For example, if I want Bien, disculpen, creo que hay un problema ahorita con la red, ¿verdad? Entonces me cerró la sesión. Bueno, ustedes quedaron aquí, es lo bueno. Okay, gonna try to do this so quickly. And honestly, like I told you before, it's just focusing formulas. The formula to find the addition of the first terms of one arithmetic sequence can be described with the next formula. Of course, there's one way to do it, like manually. You have to discover, if you want to know the addition of the first 5 elements, easy. You have to discover these 5 elements and then add them. It's one easy way. But what happens if I ask you for the 100 elements? You're not going to be enlisting all those 100, I think so. So there is a faster way, and it's follow this formula. This S and the letter N, which is a little bit like A, and there's a little condition that for these sequences, we cannot use the letter S. because the S represents the summation of these n terms, you will need next expressions or next ideas. You will need the n term, you will need the first term, and you will need which is this until what value you wanna make this addition. Okay, so we're gonna need these ideas. And essentially, this is how the formula works. There's a little problem, and this little problem is gonna be useful to understand how this formula is useful for us or for the exercise. I mean, for to understand the idea. That's my point. So, gonna leave it over there. And let's see. This is the problem. It says, how many 50-centimeter high triangle tiles will you need to cover a triangular area of 3 meters high long following the next pattern? What pattern? Okay, here it is. And I have here my tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 for the first line. 11 tiles here. How many for the second one? 1, 2, 3, 4, 5, 6, 7. Well, it's missing this one. 7, 8, and 9. 9 for the second one. And well, don't know if you pay attention on the details. Question to you. I already read the problem. I hope that you read it too. If not, we can read it again, but we must be sure about it. It says, how many 50 centimeters high triangular tiles would you need to cover a triangular area of 3 meters? Of 3 meters high. How long, sorry, following the pattern. Practically is how many tiles. Right now I'm using, to cover this space right now, I'm using 20. And of course, I know that because I have to add those numbers. Question to you, what will be the next number? Or the other question, you can answer any of those. What will be the next number of tiles we need? Or how long is the space we cover right now?
I think we are going to use 7 tiles on the next line.
7 tiles on the next line. And okay, now the next question, how many lines will you make? Because this is the second line.
3 maybe?
Just with 3, we need to cover an area and a space of
50.
3 meters. Each of these ones right now, the main characteristic is that each of these one has a height.
I think it would be
50 centimeters. Excuse me?
I think it's going to be 5 rows, 5 lines.
5 lines. Okay, so we're gonna have 1, 2, then 3, 4, 5. Until 5. Let's see how many meters do we cover. Here we cover other 50 centimeters. How many centimeters do I cover right now?
6 lines, Mr.
Ah, okay, you're gonna need 6 lines. You're gonna need
Because
one
that's
more, right?
2 lines is 1 meter then.
Exactly. So
Okay.
you're gonna need 6 lines, which means you can find out the pattern, the values in here. And at the end, find the summation of those tails and make one triangular decoration in your house with this amount of tails, if you see, okay? That's like the main idea. Of course, here, what we have to do is just discover a pattern. Suppose that you wanna make this bigger. Now, not covering 3 meters, trying to cover, I don't know, 30 meters. That's gonna be pretty huge. But I think that with this idea, you can solve this exercise by the intuitive way, like we try it right now, or discovering the pattern, discovering the formula, and then using the property, which is what we will do, okay? Use the property. So it's already 6 o'clock and we're gonna come back at 6 with 10 minutes. I'm gonna check the assistants when we come back. So I hope that you come with your ideas like clear. And if you have the solution of the exercise, it will be so good that we share it here, okay? So see you in 10 minutes. Hoy sí, mira, Mauricio. Igual, cualquier cosa ahí me avisan, ¿verdad? Les agradezco mucho.
Excelente, mister.
Gracias. Entonces, qué bien, concluimos que iban a ser 6 hileras al final las que ocupamos, ¿verdad? Para cubrir esos 3 metros y más o menos aquí está lo que se esperaba cubrir, ¿verdad? Ahí quedaría algo bien bonito, imagino que para algún parque, aunque 3 metros es muy poco, hay que hacer más. Bueno, chequeo la asistencia y luego continuamos con este ejercicio. Hoy es viernes 22, sí, así es. Y empezamos. Lourdes. Kaylin.
Here.
Mayra. Mayra Alejandra. Jenny Geraldina.
Presente. Aquí.
Okay, there you are. Then we go with Leonor. Leonor.
Presente. Aquí.
Okay, Marcela.
Presente.
Ana Ruth. Ana Lucía.
Presente.
Flavio. No, okay, let's go with Mariana.
Presente.
Then Sara Irene.
Presente.
We go with Ariel. Aurora Esmeralda.
Presente.
Emily Denise.
Presente.
Ana Gabriela.
Presente.
Jennifer Fabiola.
Presente, Lick.
Diana. Bien. Cintia Pamela. Cintia Pamela. Rixi.
Aquí ya voy. Hola, ¿me escucha? Presente.
Ok.
Sí,
Vamos
sorry.
No, don't worry. Tiffany.
Presente, Lick.
Olga. Bien. Y Mauricio.
Here.
Okay. Now I think we can continue with the exercise. And to solve the exercise, first of all, we want to be sure. Until what term do we want to get the summation? We already know that we want to get this until the 6th term. And we want to know the first term and the 6th term. So to do that, you can continue the counting here so quickly. I think this would be a good way. For example, here I start with 11, then I go with 2 less, going then or needing then 9 tiles. Then I think we will need 5. Then I think we will need how many? 3. And finally 1, okay, to cover all these spaces. Of course, here is missing like to show you the ones we have over there. And here it is. This is like the main idea. I think with this, we have like enough information to see how this formula works. One observation: what will happen if instead of work with these numbers, okay, you work with the general formula? I think is easier. If you work with the general formula, all that you have to do. Oh, sorry. I need to check over there, Anna. But I think that I marked your assistance because you connect from the beginning. Okay, that's all good. I'm connecting, always matching the 2 assistants. Okay, from the beginning and this one. And well, what I was saying, sorry, is that if you know the general formula, I think you can get any term you wanted. Right now, I think we have the first term and the term we wanted, not the last one. Okay, it's not the last one. This continues, then going with negative numbers. But the one that cares for us is the one that is in the 6th position. Obviously, you can make the addition of 11, 9, 7, 5, 3, and 1. Of course, you can do it. But the best way to do that is apply the formula. So what do we need for the formula? To get the summation until 6. Just to show you how this formula works. To get the summation until 6, You will need to know, first of all, until what number you want to get. We already know that is 6. We're going to divide this by 2, and we're going to multiply these by the addition, given by the first term and the sixth term. In this case, we have the first term 11 and the sixth term 1. And check this out. I think you can, with a calculator, can find that so quickly, no problem. You can do it with a calculator right now. And let's solve this one. By solving operation, first of all, we want to focus in the parentheses. With a calculator, you're going to have to answer immediately, no problem. So we're going to have these 12 over there. And if we operate that, then focusing left to right, which goes first. So the division, we're going to make the division first. It's, in this case, 3. And 3 multiplied by 12 give us 36. So what does it mean? It means that at the end, we need 36 tiles to cover all that area. You can make the summation. Here you make 20, 27, 32, then 35, and one more, 36. The same if you see. So any of the two ways is acceptable. But if I ask you then to find out, I don't know, another sequence, like in this one, to find the summation of the first 100 values. Okay, here you have like the option to do it. And it is so easy, it's very quickly. It's just required that at the end, you focus in how to apply this formula and of course, use it. Do you have any question about the arithmetic sequence? Any question about it?
I'm clear.
Okay, nice.
I have one question actually. I am clear with the procedure, but I want to know why you take that 6.
Why I take, excuse me?
Is it that, no, the S6, the S sub 6, you took it because of the 6 lines.
Exactly, exactly. I mean,
Okay.
remember that we want to cover 3 meters, right? And like Ana Lucia proposed, with 2 lines, you cover 1 meter. So with other 2 lines, you already cover 2 meters. With 3 lines, you're going to cover the 3 meters that problem's asking you to cover. Okay. So that's why we focus in 6 lines, because with the first line, okay, I covered the first half of the first meter. With the second line, the other half, and I complete the meter, and so on. Okay. Suppose that you want to make 4 meters. Okay, then you're going to need 8 lines. Or if I change the height of the tiles, making this smaller at 25 centimeters, then I will need 4 to cover 1 meter. You're going to need 4 lines. Okay, so that's like the main idea. And yes, that's why it's 6. Is it clear now?
Yes, thank you.
Welcome.
Maybe we can, are we going to do another example?
Yeah, we're going to have some examples at the end. Yes. So we're going to need 36 tiles, but at the end, it's so easy. It doesn't require many. I think it's very, very easy. All you have to do is focus in the elements you need, which is the amount, I mean, the value that you want to get until what value you want to get the addition, the first term, and that value. That's it. You don't need something else. You don't need everything between them. If you see, I don't focus in the 7, sorry, in the 9, the 7, the 5, the 3. I just focus in the 11 and the 1, and that's it. Okay. So that's an amazing job that in this case Gauss makes with this topic. So that's everything about the arithmetic sequence. 3 things we studied. The first one, check if a sequence is arithmetic or not. The second one is discover the formula for this one. And the third one is find the summation of the first terms that we have in the arithmetic sequence. But there's another sequence. Can you remind me what's the name of the other one? As I told you, we're going to focus in 2 sequences. Arithmetic and
Pro something.
Excuse me?
Geometric sequence.
Geometric sequence, okay? It's true. It's like that. So we can check here and the geometric sequence, which now is our topic. It's a sequence that is not following an addition. And I don't know if in statistics you ever hear like the arithmetical mean and the geometric mean. Those are a little related with this one. But in this case, the sequence, the geometric sequence, in this one, you're gonna follow a pattern not by adding or subtracting a number. You're gonna follow a pattern by multiplying or dividing a number. Multiplying essentially because at the end, you're gonna multiply fractions. And if I ask you to multiply by 1/2, will be exactly the same of divide by 1/2. So we can say just multiplication. So what you will do is discover that pattern, finding the number that multiplies the terms, okay? And that way you're gonna get the next one. As the other one, we're gonna have always the same ratio working for those. What is a ratio? Do you know what is a ratio? It's related with the next topic. Right now we're gonna see it, okay, like it is. It's just a number over another. It's like a fraction, simply like that. And I think we use ratios every day. Okay, for example, the amount of classes you pass in a year, okay? The amount of kilometers you cover in an hour with your car. Okay, so we're gonna see examples later about it, but now the topic is focusing that always those values will have a ratio between. Here's an example. Here you have this one that goes like multiplying by 2. If you see doubling the number, we have 2, 4, 8, 16, 32, 64. And I think you can tell me which is the next term, which is
72.
72. Is it 72? I mean, how do you get that 72?
Because you're multiplying 2
Uh-huh.
times 2, then 4 times 2, 8 times 2. So 64 times 2 is 120. I can't.
120, you're right, 120.
120, okay.
128.
128. Yes, there you are. Good. You got it. So it's not 72, it's not that you're adding now, okay? Now this sequence is different. And that's why it's called like that, it's geometric, because you focus in a ratio and to multiply a ratio. In this case, the ratio will be 2/1. Of course, it's just 2. Double the number, as you can see. I start with 2, then I get the double of 2, which is 4, the double of 8, which is 4, sorry, the double of 4, which is 8, and so on. Double of 64, 128. Double of 128, okay, it will be 256, I think so. Yes, 256, right? If we can continue,
Yes.
like getting doubles and doubles every time, okay? That's like the main idea of this sequence. Now, this is a little bit tricky and a little bit complicated sometimes in the sense that focusing the other 3 elements, okay? Focusing to check if it's a geometric sequence, focusing to check if like how to get the end term, and focusing the summation, especially the part of the summation, because sometimes the values we get are so small that in our calculators immediately, or the calculators understand this one's like 0. So don't worry about it, and we will try some exercises that describe as well these formulas, okay? So to check, for example, if these, which is the description, the formula that describe any of these values, is or makes a geometric sequence, we have to try this property. As we did it with the other exercise, we're gonna have the same, just that instead of make a subtraction of those, we're gonna make a comparison, a ratio, a division between those values, expecting to get that ratio. So this is the way to describe, this is, we're gonna see then, okay, because probably that's your question again. How can you discover this one? We're gonna see it in the next slide. But focus on this. If you see, for example, if I'm focusing the fourth term, which is 16, how can I get 16? Let's see, a sub 4, which is the fourth term, will be given by the multiplication of the product of 2 times 2 raised to the power of 4 minus 1. Is it gonna be 16? Let's see it. 2 times 2 at the power of 3. 2 at the power of 3, and I'm checking here if you remember the exponents rules. 2 at the power of 3 is, it's multiplied
9.
8. It's 8. Excellent. Is 8. And then 2 times 8 is 16. As you can see here, we describe with this formula all those values, which means that now we can try and check if this is a geometrical, in this case, sequence, right? Which is what we want. The rule says that what you have to say or what it stays between those values is always a ratio. Let's see. Yeah, we already discovered that the ratio between them is 2 because you're gonna get the total of the next one. Okay, let's see it. So I think that if we know the formula goes like 2 times 2n to the power of 1 for a sub n. The next term, which is the consecutive one, is gonna be given. Sorry.
And this is the same thing that the formula will change, and then we'll find it like the, okay.
But in this case, it's not a subtraction, it's a division. It's the same thing if you see, just that now working a different context. Instead of work with n, we're gonna work with n plus 1. Of course, I'm just replacing this. I want that you focus like in some of the principles that you were using or saying in the investigation you did to participate in the last forum. Okay, same idea here, just that I'm applying those. I'm applying those principles. So a sub n plus 1 will be just developing a little bit this, because you're gonna make a subtraction between those values. I mean, we can solve this one apart if you want. Like, what is n plus 1 minus 1? Come on, what happened? The one and positive and the one negative, like canceling each other, it's just gonna be n. At the end, this is just like 2 times 2 at the power of n. Now, becomes a lot simpler. And let's see now what will happen. If you remember, what we want to do with this division, comparing this expression with this one, is then conclude if they really makes or not the ratio that works in our exercise. What was that ratio or that number? Do you remember?
The general term.
It's 2, right? It's 2, right? The number that was working in the pattern, okay, was 2. I mean, the double of the last number. It's the main idea. So let's try it. Let's use the rule and see if this really works or not. On the top, we're gonna have this expression, which is 2 times 2 at the power of n over the other expression, which is 2 times 2 at the power of n minus 1. Okay, so here we have some properties. Honestly, this is gonna be a little bit related with what we will do and with polynomials, of course. And we wanna know if this really is equal to 2. I don't know, we're gonna see. So to do it, we wanna focus in, try to simplify these expressions. You're working ratios in here. So you can simplify this 2 with this 2 very quickly and immediately focus in the variable expression. Having 2 at the power of n divided by 2 at the power of n minus 1. Let's see, do you remember what property applies in here? This is a little related with what happened if you have 2 at the power of 4 over 2 at the power of 2, just to show you an example. Do you remember what to do in those cases? And check this out. I'm moving these cases, these ideas, these properties. Well, nobody mentioned one of those properties the last time in the forum. Many of you focus in distributive, associative, didn't focus like in the properties of exponents. But I think we know the properties of exponents. What happened with those exponents? Do you remember? Especially that they are working the same base.
They're added, both of
They're
them?
added, okay, they will be subtracted. So you're gonna have 2 at the power of 4 minus 2, but so good. I mean, you remember, you don't say you're gonna have then a weird expression over there. No, it's you add them when you multiply those. When you divide them, you're gonna subtract those. So using this idea and using this property over here, you're gonna have then 2 at the power of n minus n minus 1. Same situation we were with the last exercise. So we're gonna have n minus 1. We're gonna solve it here apart. Distributive property with that negative sign. It's not that's gonna affect just the n, okay? I hope that you never forget that. You're gonna have then n minus n plus 1. And what happened with the n and the n? They make 0, right? Positive n, negative n, they cancel each other. At the end, this is just 1. What do we have here essentially is 2 at the power of 1. Question, what is 2 to the power of 1? It's 2. Finally, we discovered that this is really 2. For that reason, we can say that this makes a geometrical sequence. Or we are 100% sure of this to say it with this little proof we made. So this is the way, and if you see it's a little similar to the other one, just that you use other properties. There he is. So pretty easy and I think easy to understand the idea of the sequence. And what we want to focus on now, it's in the other 2 elements, right? Or in the other 2 characteristics, like how to get this rule, and how to get the summation of some values, okay? So let's go there, and then if you have questions, you can make it. Or now, if you have any question about this part, you can make it. Any question? Clear?
It wasn't that clear. I'm gonna be honest.
Okay.
I know right there when you said use the next property and you have those squared in orange, in yellow.
Uh-huh.
So you got that formula, the property, the a sub n plus 1 divided by a sub n equals r.
Uh-huh. I got it. I mean,
and you just move.
Is what we create from the beginning. We say it.
Uh-huh.
The way to check if it's a ratio, I mean, if it's a geometric sequence, sorry, it's focusing if always you're gonna have a ratio between any 2 consecutive values. Of course, we're not gonna be trying with, I mean, here we can try with 2, with 4 and 2, with a and 4, with 16, but you're not gonna compare them with like the number which is in the 100 position. I think so. You're not gonna try it, right? I mean, will you try all those values to see if they really makes that division 2? Don't know if you understand my point. Yes, so that's why we focus in the general form that describes any of these values, and we focus in the value we want and the next one, the consecutive ones. Just what I'm doing over there is like translating to math sentences these lines you have over here. Okay, you're always want to have a ratio between any 2 consecutive numbers. That means this. So this is the main property, as we did it with the last one. With the last one, we did it like this. The number stays between any 2 consecutive numbers, just that here we have a difference, right? We have a difference. In the other one, we have a ratio. Okay, that's why we make the comparison like that. So that's why it's not that I create a rule. The rule is over here, just that it's in words. I translate it to the math language and we use it to see if that really works. and it really works. Okay, let's go now to the other two elements, focusing this, the geometric sequence. To get any geometric sequence, to write any geometric sequence, sorry, what do you need? So similar to the other. Make an analogy, and you're gonna see that always you're gonna need at least the first element. It's basic, first element, and then the ratio that will be given by the comparison of two consecutive numbers, which implies then that if you have a list of numbers, you're gonna focus if they really follow a pattern, you're gonna focus if what's the number that works between them, how? Making a ratio as we did it with the last exercise. Or making a division, I mean, as we did it with the last exercise. Where we have 4, 8, then you can divide 8 by 4 and got the ratio. Or in general, the term, the consecutive term, which is n plus 1, and discover what is it. So if I ask you for what is the general form of next geometric sequence, can you tell me what is it? First of all, we want to focus in the first term. Do we know the first term of this sequence? Yes. And is?
4.
It's 4. So we have to focus in that 4. We already have it. Nice. What else do we need? We need the ratio. For that, we're going to suppose that it's a geometric sequence, okay? We're going to suppose that it's a geometric sequence. To prove that it's a geometric sequence, okay, you know what to do, but we're gonna say that it's a geometric sequence and get that ratio. Now, how can you get that ratio? Which will be the number that probably multiplies the last one to get the new one and so on.
Would it be 12 divided by 4?
Exactly like that. Or 36 divided by 12, or 108 divided by 36. Any two consecutives, the rule we used in the last slide. Okay, so I think you got the idea. Nice. So what's gonna be that ratio? Any two consecutives. Okay, I'm gonna get 108 divided by 36. You can simplify it, or you can make the division mentally if you want it. I mean, 90 and 18 more makes 108. That's 3, right?
Yes.
Yeah.
Excellent. You can try it with any, with those, of course, you're gonna compare the consecutive, the last consecutive, or the number next to with the number before, okay? So that's the idea. It's not that you're gonna make 4 divided by 12. No, you're not following the rule over there. The rule is compare the consecutive with the other one. So the value of R is 3, and the way to write this one, it's quicker than the other one. It doesn't require many procedure, honestly. So the formula, the general form of these can be written so quickly as an equals to your first term, which in this case is 4, your ratio, which in this case is 3. This could be a fraction, okay? This could be a fraction. And the exponent will be n minus 1, as you can see here, following that formula. And that's it. You don't have to do some procedure over here. Honestly, I'm not going to ask you to do some procedures over there. So there he is, n minus 1. There he is. So simply like that. And with this, what can we do? We can get the n term. We can get the 5th term, for example, of this one. Or we can get the 10th term. Let's get the 10th term just to see how big is this one. Because I told you, and you told me at the beginning too, that this sequence goes increasing or goes decreasing. Okay, this one goes increasing a lot, I think. Just with 10, you're gonna see what a big number you're gonna have. You're gonna need calculator.
So A sub n, that's the formula, right? The one we have here. We got the formula.
Yes.
Okay.
You don't have to do something.
We don't
else
need to
here.
solve it. Okay.
Yes, you don't need to do something else. That's it. You don't need to solve it. That's it. What will be that value? It's a big number. Try it in your calculator. I mean, here it's gonna be 4 times 3 to the power of 9. Just 3 to the power of 9. It's a very huge number. Try it over there. If you have scientific calculator, you can try this. 4 times 9 raised to the power, sorry, not 9, 3 raised to the power of 9. What a huge number. And if you see, I'm in the 10th position, not too far away. I didn't ask you for the 100. You're gonna see another big number, I think so. So what's the number? Who can tell me? I don't know if you already try it.
19,683.
90,000?
19,683. I think it's
19,683. 19,683. How do you solve it in the calculator?
with the exponent 3 through to the exponent of 9 x.
And then it's missing to multiply it by 4, I think so, or not? Did you multiply by 4, Jenny?
No, not yet.
Okay,
Sorry.
it's missing multiply it by 4 because the number is huge. I mean, yeah, this is part of the procedure. This is gonna be like 4 times this. Essentially, what you have over there is like 3 to the power of 9. Okay, let's write it. This is gonna be 4 times this number you told me, 19,683, and yeah, 4 times this will give us like 70 something, I think so. 70, yes, it's give us a big number, right? 78,000. I think you try it.
78,732.
Yes, that's the number. Y si fuera dinero, qué bueno, ¿verdad? But that's the number, I mean. And yeah, with this one, with the geometric sequence, you have like 2 options. Normally, with the arithmetic sequence, the number just grows a lot. Yes, I saw Mauricio send it in the chat. Thank you. The number grows to the positive values, to the positive infinites, okay? And or the numbers grows or decay till the negative infinite. Here, not. In this one, the numbers grows a lot to the positive infinite or decays very quickly to 0, okay? That's like a interesting difference between those. In geometric sequence, those decays, but decays to 0. Okay. So this is the way to get the general form. Let's see now how to get the summation of the values. For the summation, you're gonna do something a little interesting in the sense that you require to focus in the formula a lot. Right now, it's just like use the formulas. Okay, we still haven't yes, we still having time to do some exercises. And then conclude the class. We conclude at 7. So let's see. To find the summation, geometric summation in this case, for the addition of the first term in a geometric sequence, you can use the next formula. The formula describes, or to use the formula, I mean, you require the first term, okay, which is something you need in the last one, but you don't require like the term you want to be. No, you don't need that. You just need the position, the value you want to get. Until what value you want to get? Do you need the value? No. Now, what you have to do is a comparison with those ratios, another ratio with the ratios, a new ratio. And this ratio is called the complementary one. And this is the complementary one because essentially ratios normally works with fractional numbers, and you complement the fractional numbers. Someone has a question?
The summation then, from reading what it says on at the bottom, like determine the first n terms, right? Like you add them. It's like just adding the term.
For example, if I ask you for the summation, if I ask you for the summation of the first 3 terms here, easy. Add 4, 12, and 36. But if I ask you for the summation of the first 10 numbers, well, I think the number is going to be bigger than this. That's the only thing I'm sure. but it's gonna be very huge too. So that's the summation. That's the idea of the arithmetic sequencing here.
Okay.
But the competence here is use formulas, honestly. That's what I want that you develop here. Use formulas. So let's see how can we use that formula. I want that we determine the sum of the first 5 terms. Look, I'm not asking you to make many terms. So, which implies that you can get the 5 terms and make the addition. Best way if we apply the formula, okay? It's better if we apply the formula. Just a little question, because that's the general form of the sequence, is this one, okay? Do we know the ratio? Do we know the first term? Do we know the ratio in the first term?
Yes. Are we doing it from the last example? Or
No, this is a new one. I'm asking you to determine the sum of the first 5 terms of this geometric sequence, of this one. So how can we get it? We need to apply this formula. Okay, let's move the formula over there. I think it's gonna be clear that way. So what do we need to apply the summation formula? We need the first term and we need the element until what element, not the element, until what element do we want to be? We want to add. So we are clear the value of n is 5. Now, are we clear with the first term and the ratio, which are like the other 2 things we need? Because at the end, we want s sub 5 to get this addition. So what is the first term? Let's see if you already understand like what means this. What is the first term? But remember,
Number 4.
it's 4.
it's 4. Okay, it's 4. Now, what is the ratio? What is R? I mean, we can write this ones over here. The first term is 4. The ratio with 1. What's the ratio? It's over there too. The letter
It was-
R. It is?
It was
It's
5.
It's 5. Excellent. It's 5. So there you have the information you need. With the geometric sequence is easier to get the summation in the sense that you would not need like many things to do on the formula. But on the formula, we have to focus and be careful with how we use it. So we have the first term and it's gonna be multiplied by 1 minus the ratio, and the ratio will be raised to the power of 5. So it will be 1 minus, in this case, let's write it over there, 5
To
to
the
the power of 5, excellent, over 1 minus 5. Okay, here we go with this interesting exercise. Let's solve it by parts. Recommendation, solve the top part first, and then we will see what happened. On the top, I'm sure you're gonna have a negative number. On the bottom, the same, another negative number. So that way we can conclude that summation of these ones and then multiply this one by 4. That's like the interesting part, okay? So what is 5 to the power of 5? I think we can focus on that part. What is 5 to the power of 5? It's like
3,125. I'm not sure.
3125.
I did
Yes,
it.
yes, 3125, 3,000. Yeah, there are some tricks you can do to get, especially these powers. Okay, it's true. In this case, is like you say, 3125, 3,100.
25.
Exactly. There he is. That's going to be over 1 minus 5. But I think we can solve 1 minus 5. Let's solve it later. Okay, 1 minus 5. Now, let's get this resolved. And remember, we're going to multiply this by 4, right? So that's not all. On the top, we're going to have, let's see, the subtraction of this one. It gives me, well, negative 3,124. divided by -4. Let's make that division. And then we're gonna multiply this by 4. Real number properties. What happened when you divide two negative numbers?
It will become positive, and it is 781.
781, thank you. So we're gonna multiply 4 times positive 781. There you is. There it is.
3,124.
And that's the summation. 3,124. That's the summation of these geometric sequence of the first 5 values. What happened if I ask you of the first 10 values? Wow, it's gonna become very huge, okay? So any question about it? With this, we conclude everything about the sequences. It's an interesting topic, this one. And if you see it, have some applications in real life. Don't know if someone works in investment here. Last time I asked about it, but there are some ways to calculate, for example, well, I don't know the word in English. Y para no inventar, mejor lo digo en español. Por ejemplo, la depreciación de un artículo que ustedes estén utilizando para generar, vaya, por decirlo así, si habláramos de una pizzería, sería el horno. Ese horno sufre una depreciación. Normalmente esos modelos se deprecian, perdón, esos artículos se deprecian siguiendo una secuencia geométrica, ¿verdad? Obviamente que en vez de ser un valor grande, va a ir haciéndose un valor pequeño, porque la idea de una depreciación es que va perdiendo un valor por el uso, obviamente. Si yo hoy compro un horno a 5,000 empiras y después de 5 años lo quiero vender a lo mismo, me van a decir, estás loco, ¿verdad? Nadie me va a dar ese precio, ya se ha depreciado. Okay. So here you have it, and if you have any question, you should make it now.
On Sunday, that we're going to have the quiz, this type of exercises, they're going to appear, right?
Yeah.
Are you
Yeah.
going to provide the formulas?
I mean, you have it here, you can copy it. And
Oh, yeah. Well, but we can use them, obviously, right?
Of course, is the idea, because the competence is use formulas right now. Okay? And yeah,
Okay.
it's true. On the test, you're gonna have the options over there, or probably I will ask you to write the answer. Okay, we're still having like some minutes to practice some exercises. As you can see, I prepared some of these ones in here. And well, here I have this one. Identify if the sequences, if the arithmetic and geometric sequences, okay, sorry, that's wrong. Instruction is totally wrong. Identify if the sequence is arithmetic or geometric. Very like that. Or geometric sequences. That's what I need. How can you identify that? How can you be sure that you have a geometric or arithmetic sequence? For example, is the first one arithmetic or geometric?
The first one, arithmetic.
The first one is arithmetic sequence.
Okay, and why is arithmetic? Look, that in math is not enough to prove that the difference between those that is 5,
Because of the ratio.
5, the difference is 5. In arithmetics, you focus in difference. In geometric, you focus in ratio, okay? But if you see, I even tried with all of them, and the property says that it's gonna work in every consecutive element. Honestly, mathematically, it's not okay if you say that, yeah, that's an arithmetic sequence, just because I already tried with the first, second, third, fourth, fifth element of the sequence. Come on, what happened with the 6th, the 8th, the 10th, all the rest? What do we have to do here? We have to make the proof that the difference between any two consecutives, I mean, this it's equal to 5. Okay? So this is like the mathematical way to do it. I'm agree with you right now, concluding that this is arithmetic, just because of the time, okay? What happened with the other one? Of course, your job is find out what is a sub n. How can you find it? Okay, you have over there the formula. Don't remember the formula. It is a sub n equals to, if you remember, your first term plus n minus 1 times d. That's the formula that you're going to use to find out a sub n and then a sub n plus 1 in order to make this proof. This is how mathematics works, okay? Of course, we're not going to do it right now. We don't have enough time. And I want to explore one of those, sequences. Let's see the second one. What do you think? What's the second one? Is it arithmetic or is it geometric? Is there a difference that stays between those? I mean, here is 4. Well, here the difference not gonna be 4. Now we start working fractions, right? I mean, we're gonna have something different in here. Probably not a difference, probably a ratio. Do we have a ratio between them? What do you think? Try it. It's just like pick any of those consecutive values and then make a division. Of course, that consecutive with the one that is before. For example, with 6 and 2.
It's geometrical, and I think it is 1/3 would be the ratio.
Excellent. The ratio that's working between them, it's 1/3. Again, it will be acceptable to me that if you try it this way and you discover it this way, but mathematically, we have to try with the rule, with the formula. What is the formula? The formula is compare the consecutive value divided by the next one. I mean, by the one that is before, and see if that ratio works over there. How can you get the general form of this one? I think we already see it right now. Well, in this case is bn, so we're gonna write it like bn in the formula too. So all is just use formulas, as I told you, okay? If you're clear with the formulas and you have it over there with you at the moment to solve the test, I think you're gonna have a really good score. Okay, there he is, there he is. And of course, what was the general form to write this one? Can you remind me? What was it? Or how was it? It is the first term multiplied r at the power
n minus 1.
N minus 1. You're right. Of course, with these, you get the general form of the formula, which describe any of these values here. And then you have to apply it like we did it over there to discover if the ratio at the end really makes 1/3. Okay, here comes one interesting way and one interesting sequence. And with this, I'm gonna conclude. I'm missing just 2 minutes. Don't really like to take more time. We have the sequence 1, 1, 2, 3, 5, 8, 13. Have you ever seen this sequence before? I mean, is it arithmetic?
Minus 1 is the first term, mister.
No, it's 1.
It's 1. Interesting.
Yeah, that's so interesting because it is start with 1 and 1.
It is adding by the next number.
And for example,
no, there's a ratio of 1.
It's a ratio or it's an addition? That's so interesting. I like the idea that Jenny is saying, Jenny Teruel. So what will be the next number?
21.
Oh my God, 21. Why 21?
Well, I did I was adding 8 plus 13. We're adding in that sequence.
Have you ever seen this before? Yes? Have you ever seen okay, yo creo que por su sangre, por sus venas, por su sangre, perdón, por sus venas corre la sangre de Fibonacci. ¿Ok? Un personaje muy famoso, que de hecho es gracias a él que hoy entendemos esos símbolos que llamamos números como números. Entonces, por sus venas ha de correr esa sangre, porque ella sí descubrió. Jenny ya descubrió cuál es el patrón. O sea que Jenny estaría de acuerdo conmigo si le digo que el siguiente es 34, ¿verdad que sí? Sí, ok, sí, ahí está. Por sus venas. Si no lo había visto antes, por sus venas corre esa sangre. Bueno, es lo que dicen cuando alguien descubre este patrón. No sé si nos puede describir cuál es el patrón y con esto pues culminaríamos la clase. Solo les comparto ese video de YouTube para que lo vean ustedes y vean qué bonito es este número. Porque esconde cuatro rarezas. 4 rarezas matemáticas y esconde un montón de bellezas de la naturaleza. Si nos describe cómo fue que lo encontró. I think you're mute.
Tiene el micrófono.
Oh, sorry. Okay, what I did was like 1 plus 1, that would be 2. Then 1 plus 2 would be 3. 2 plus 3 is 5. 5 plus 8 is 13. And so on. 8 plus 13 would be 21. That way.
Así es.
And then you added 21 plus 13.
And that's going to give us 34. And then 21 plus 24 is, and so on. Ok, les voy a dejar este video de YouTube. Se los comparto por ahí. Véanlo, tómense un ratito. No recuerdo cuánto dura, pero no dura mucho. O sea, no dura 3 horas. Ahí está. En vez de ver un TikTok o una historia de Instagram, vean ese video. Van a ver qué bonito. Okay.
Mister.
Perdón,
Ana.
No. No, just on the exercise, los primeros, we just need to find the formula.
Exactly.
No, and okay.
In this one, okay, watch the video. Because it's not an arithmetic sequence, it's not a geometric sequence. It's a famous sequence in math. And you will see that it's not just of math, okay? You will see. So check the video, please. Want to say something, Mauricio?
Sí, mister. Este ejercicio, no sé si es algo así como el de los, no me recuerdo bien, de una persona que le pidió a un rey que le tenía que pagar, digamos así como por con unos granitos, los granitos, no me recuerdo cómo era, pero que iba a poner, digamos así como en el tablero, en un tablero de ajedrez que tiene 64 cuadros, que en el primero iba a poner un granito y que el granito iba a equivaler a no sé cuánto de terreno. Y entonces el rey aceptó y le dijo que, claro, él tenía, creo, algo así como una secuencia, una sucesión que iba a seguir y que le iba a dar al siguiente día lo del día, algo así como este, digamos así como para
lo
sacar
sumado del anterior.
Ajá, le iba sumando al anterior, y entonces, bueno, creo que el rey, pues, aceptó porque lo vio que no iba a ganar mucho, pero al final, pues, no sé, salió perdiendo, pues, porque, claro, el que le hizo esto, pues, así como conocía, y el rey, pues, tristemente, ¿no?
Como que no. Pues no sé si está relacionado con pero lo que sí le voy a decir, y no le voy a mentir, si ustedes han visto, bueno, vean el video, es que yo no me quiero adelantar, no les quiero hacer spoiler del video. Miren el video, está bien bonito. Ahorita quería verificar como cuánto duraba para ver si no era algo que se iban a estar ahí estresando viéndolo tanto tiempo. Aunque tome ese tiempo, yo les sugiero que lo vean. Véanlo y lo van a disfrutar porque ese número.
Can you share the link in the chat? Sorry.
Dígame.
Can you share the link in the chat because I can't.
Ok, ya lo compartí por acá. Creo que solo se lo compartí a una persona. Igual lo compartí en el de WhatsApp, ¿verdad? Para que lo vean. Y sí está bien interesante. Pueden verlo ahí. Permítanme. Dura como 5 minutos, pero son 5 minutos que no se van a repetir para nada. Bueno, yo dejo la clase hasta acá, más bien ya les robé tiempo. Les recuerdo, mañana nos vemos a las 10, ¿ok? A las 10 de la mañana, en compensación de que vamos a estar de 1 a 2 en la capacitación. Y yo les voy a compartir de igual forma el link, ¿verdad? Aunque ya lo tienen algunos, pero sí voy a chequear asistencia, así que es obligatorio conectarse allá. Igual la licenciada Odessa va a verificar y va a cotejar con nosotros quienes se presentaron, ¿verdad? Bueno, hasta mañana entonces, si Dios lo permite. Feliz noche.
Feliz noche,
Gracias.
gracias.
Bye.
Bye.
Buenas noches.